Today we are looking at a 2 op-amp instrumentation amplifier, and this is how the circuit would look like. We'll use 2 op-amps instead of 3. If you don't know what instrumentation amplifiers are, then I would suggest you watch this video first. Well, an instrumentation amplifier is an updated version of a difference amplifier which amplifies the difference between two signals and cancel out the common mode signal. We're using 2 amplifier circuits one after another. A great legendary Indian YouTuber once said,
तीतर के दो आगे तीतर, तीतर के दो पीछे तीतर,
सब एक दूसरे के भीतर.
yeah, just like that. It is made up of a non-inverting amplifier and differential amplifier with the negative feedbacks. Apart from that, we'll use one more feedback from the input of the second op-amp to the inverting terminal of the first op-amp. And this resistor is very important because it sets the gain of the amplifier. And here we add one resistor between two amplifiers. Now we'll design a 2 op-amp instrumentation amplifier for 2 signals, which has the minimum difference voltage of plus or minus 1 volt and maximum it can be plus or minus 2 volts. The common mode voltage of the signals will be plus or minus 10 volts. That means these signal inputs vary from minus 10 volts to 10 volts together, but the difference between these two will always be either 1 volt or 2 volts. For the signals, we want output to be at least plus or minus 10 volts. So for that, 15 volt supply of VCC and VEE are sufficient. Now let's design this amplifier. As always, the value of these input resistors should be selected considering the output impedance of the input source. The value of these resistors should be larger than the source impedance but not too big or it can degrade the phase margin of the circuit and add additional noise. If we remove this RG, then R3 and R4 set the minimum gain. Ratios of R2 by R1 and R4 by R3 must be the same to avoid degradation in the amplifier's DC CMRR. We can vary the gain. This RG helps us in changing the gain register. Considering all, this would be the transfer function, or we can say the relationship between output and input voltages. This is the gain of the amplifier and it is given with this formula. So our maximum input voltage difference will be 2 volts and we need output as 10 volts. So we need at least gain of 5 volts per volt for this amplifier. This is a non-inverting amplifier, so we have to use the non-inverting gain formula to calculate the gain. And as we saw, R3 and R4 set the minimum gain. So we can use this formula to calculate the resistor values. But there are 2 variables and 1 equation. Here we have to assume one resistor value. We'll select it as 20K. So from these, we can calculate R3 value, which is 5K. But I'll select 5.1 kilo ohm, which is a standard value and readily available. Now we need to calculate the values of R2 and R1. Well, we have to make our life simpler. So as we saw, these resistor ratios should be similar. So using this formula, we get the values of R1 and R2 as well. Now we can calculate the value of the gain resistor RG with a gain setting formula. We need a maximum gain of 10. So using this formula, we can calculate the value of the gain resistor, which is 8K, and we'll use 7.87K, which is the standard resistor value. We can also simulate this circuit using TI software from TI. I've added the link of the simulation files in the description. This circuit has the obvious advantage of having only 2 rather than 3 op-amps, and it provides savings in cost and power consumption. However, the non-symmetrical topology of 2 op-amp instrumentation amplifier circuit can lead to several disadvantages, mostly in lower AC CMRR compared to 3 op-amp instrumentation amplifier design. The input resistance is high and balanced, so it is acceptable if the signal source have unbalanced output impedance. This circuit can't operate at unity gain. It has a poor CMRR because of the unequal phase shift in the two inputs. Because the signal must travel through amplifier A1 before it is subtracted from Vin2 by the second amplifier. So the voltage at the output of A1 is slightly delayed or phase shifted with respect to V1. When there is a gain need of at least 5, we can use 2 op-amp instrumentation amplifier circuit because this has a good DC common mode input range as well as sufficient bandwidth with most of the applications. And that's a wrap. I hope you picked up something useful from this video. The reference of this design is added in the description below. While checking the reference, don't forget to hit that subscribe button as well. It's right over there. I'll see you in the next one. Till then, stay hungry, stay